So our next derivative rule tells us if we're taking the derivative of two different functions added together, then basically what we're saying is the derivative operator will distribute over addition. So we can distribute that derivative to the f function, and we can distribute the derivative to the g function. So that will allow us to write it like this: derivative of f plus the derivative of g. And this also applies to subtraction. The proof of this theorem just follows from the fact that limits will also distribute over addition or subtraction. And we know that definition of a derivative is just... So let's work on an example using this new rule. So in part A, we have the derivative of 5x cubed minus 7. So the first thing to do is use the rule we just talked about and distribute the derivative to this guy and to this guy. Okay, so first of all, let's look at the derivative of this. Well, that's just the derivative of the power rule, but we have this constant. So you could pull the constant out if you want to. So that would be 5 times the derivative of x cubed, which would be 5 times 3 to the x times x to the 3 minus 1, so 2 power, which would just equal 15 times x squared. So we know that this guy will equal 15x squared. Remember, the shortcut is just to take this 3, multiply it by that 5 to get the 15, and then you take the 3 and subtract 1 from it to get the new exponent of 2. Alright, and what about this guy? Well, 7's a constant, so it equals 0. Taking the derivative of a constant equals 0. So then our answer is just what we got from this part, which was 15x squared. So our answer, or our derivative, is 15x squared. Okay, now for part B, we have the derivative of this guy. The first thing to do is distribute the derivative. So we distribute the derivative here, here, and here. And also when I rewrite that, I'm also going to rewrite the square root of x as x to the 1/2 power, using that nth root rule. And also 5 over x, I can rewrite that as 5 times x to the negative 1 power, using the negative exponent rule. Okay, so now I've done that here. Alright, first let's look at the derivative of 24x. Remember, you can take that constant 24, put it on the outside. So then you're just taking the derivative of x. But we know the derivative of just x would just be 1. So then this guy will just equal 24. 24 times 1. Okay, for this guy, I need to use the power rule. So my exponent of 1/2 comes out in front as a coefficient. And then I have x to the 1/2 minus 1, which would give me negative 1/2. For this derivative, I have a constant 5, so that's going to be on the outside, 5 times, and then my negative 1 exponent comes out front, multiplied by x to the negative 1 minus 1, which would be negative 2. So then I just get 5 times negative 1, which is negative 5, times x to the negative 2 power. Okay, so let's write down now what we have. So that's what we have now, and we can simplify a few things. I can use the negative exponent rule and the nth root rule to rewrite that, and also the negative exponent rule to rewrite this. So then I can write my final answer this way, which just looks a little bit neater.